Hello everyone. In this session, we are going to learn about AWS Identity and Access Management. We will start learning AWS IAM users, how to create them, how to enable multi-factor authentication, alternatively known as MFA, how to create access keys and secret keys for programmatic access. Maybe you want to access AWS through some kind of a SDK like .NET SDK or Java SDK. We will then go into IAM groups, learn how to attach permissions into multiple users using IAM groups. We will then learn IAM policies, some basics around that, differences between AWS Managed policies versus customer managed policies, and also what's the purpose of things like inline policies and permission boundaries. We will go into IAM roles, learn about IAM role trust, how to use IAM roles with AWS services. This is a foundation course. I will try to demonstrate all of these activities in a real AWS environment so you can try them at home. More advanced topics around AWS Security Token Service, single sign-on, identity federation, and AWS Cognito will not be discussed in this tutorial, but I will put links for more advanced tutorials down in the description of this video. Let's start with IAM users. IAM user is the basic construct that you will find in IAM user console, which allows you to access AWS. I'm in my AWS console. As you can see, I have logged into Sydney region. So if you are from different parts of the world, maybe you are using a different region. The concept around region we already studied in one of the previous video. So feel free to look that to understand what AWS region means. So to access AWS Identity and Access Management, you can go through this recently visited service section. Alternatively, if you go into the security and identity compliance, you can see that IAM is the first one. That itself tells you how important the identity and access management in AWS world is. Usually when you access this one, you go through the search bar and then type IAM. That will give you access to the IAM section of the AWS console. The first thing to notice is that IAM is a global service. So if you go here, the region, all the other regions got disabled. So you cannot select like whether it's a Sydney region or Singapore region, you cannot select it. It is because it's a global service. So any users that you create here is available for any other region in AWS. So let's first go into the user section of IAM console and then try to create a user. Let's go there and then add a user. So user can represent a human being. So you can give something like John Smith. The first name and first name dot last name is very common in different AWS environments. Alternatively, a user can also represent an application. So you can say, for example, my app. So usually, if you are using my app, you are going to give it a programmatic access. So this is where you will access AWS through AWS command line interface or AWS software development kits like Java development kit or .NET development kit. So for the moment, let's create a user called John, and we are going to give AWS console access. So if you select AWS console access, this user called John will be able to log into AWS console. So when I say AWS console, the console is this one that I'm using right now. It's like the graphical user interface that usually the users interact using a web browser. So I give the console access. I can give the user a password. So if you select the custom password for this AWS environment, so I give a password, and you can specify the user must create a new password at next sign in. So what it means is that when user logged in, he will be prompted a new window to change this password. So let's keep this one on. If you don't select this password he can reuse when he logged in. The programmatic access, you can have both console access and programmatic access. So what it means is that the user can use that these access keys maybe to interact with AWS using command line. For the moment, we'll just leave it blank. You can always come later and then add this. If you give access to programmatic access, you can always later come and then give access to AWS console. And then let's go and then add permissions. Permission is where you specify what kind of things the user can do inside AWS. For example, if you want user to access only specific AWS services or fiddle around with only specific AWS resources, you can specify under the permission section. There are different ways you can do this. One is that, like any other application, you can attach the user to a group. You can create a group here. Alternatively, you can add the user to an existing group. This allows you to directly, instead of attaching permissions to individual users, manage a group of users together. For example, you may have IT support team that has only read access to AWS. For the moment, we don't have any groups. Let's create permissions and then directly attach into the user itself. If you go here, the filter policy and select AWS Managed policies, the one that appear here are the one that AWS give by default. These are really good to quickly give some permissions to the users. There are a few use cases for AWS Managed policies. One is, of course, as I mentioned before, it's easy to use. You don't need to go there and then attach your own permissions. Let's say you want to have S3 full access. You just go there and then use S3 full access. The other use case is there are some AWS services that need certain access to your account. A good example is Simple System Manager. So when you are creating an EC2 instance and you want to let AWS System Manager to communicate with certain AWS services, because the agent running inside your EC2 instance need access to certain AWS resources, you will use some of these permissions. So if you look at Amazon EC2 role for SSM, which is a role that you usually attach into EC2 instances when you are using a Simple System Manager, that Simple System Manager needs certain AWS access. So that includes things like ways to communicate with Simple System Manager and also to allow certain EC2 messages, read permissions on them. Now for that to operate, that agent to operate, you need these permissions. So instead of you going there and then defining, you can easily go there and attach this permission. So time to time when AWS improve this agent, for example, they will do updates into this so that you will have fully working functionality of that agent without you needing to go in there and update these permissions. There are so many other such services. Another example would be CloudWatch agent. So there's another agent called CloudWatch agent that you usually install on EC2 instances. So they are also like, instead of you going there and then defining all the permission that this agent needs, you directly go there and then attach these permissions into the role attached into EC2. So that way you can provision the absolute necessary permissions so that it allows you to communicate and get these services working. So now you know the use cases for AWS Managed policies. But when you go more advanced topics in AWS, or if you are managing production environments, you don't usually give these managed policies. You will probably give a fine-grained policy that you create. So those permissions that you create by yourself are called custom policies. And if you have one, if you select this one, you will see those custom policies appearing here. As of now, I don't have any custom policies, but later in this tutorial, we will go into and then create some custom policies and then attach this one to the users. Let's select a very simple manage policy for Amazon S3, our favorite service, which gives me access to Amazon S3 full access. So I have pretty much full access to Amazon S3. And this is why usually you don't use these managed policies. This gives you complete control over that service. But when you go into more advanced topic, you are going to restrict this one. We will go into this policy document later in this tutorial series and then learn how to create more custom policies. So for the moment, let's leave this one as S3 full access and go for the next stage. You can also attach a key value pair. So this is useful if you have a lot of users to identify, for example, which department they belong into or what application categories they belong into. So you can, for example, you may have something like department equals HR. You can have something like app category, right? Equals, let's say, something like finance. So you can define these categories that allows you to restrict certain permissions and also later find these users using, for example, AWS resource groups. We don't need this one in default, just we leave them as blank and just go for the review and then create this user. Now I created this user. Now the question is how we can access AWS console with this user. To do that, you need to log out from this existing user and then use this URL to log in. An obvious question is, what if you forgot that login URL? You can always go to the user and then select the user, and if you go into the security credentials, you can find that console sign-in link. It's given here. And it always starts with HTTPS, the account number, .signin.aws.amazon.com.console. You can change the login URL if you go into the dashboard, and you can customize this sign-in URL. Instead of using AWS account ID, you can specify your own domain, provided that domain is not taken. Like for example, I can specify something like my awesome, something like that, create the alias. Luckily for me, I have that area. So now the login URL is myawesome.signin.aws.com.console. You can change this URL later if you want. You can just go to edit and then click my awesome 1, for example, and then save it. Now, having this URL does not mean that users can't log in using the previous URL. So if you go into the users and then select the user security credentials, you can see that the user can still access with the account ID followed by the signin.aws.amazon.com console. So they already have, this is just to make sure that you have a user-friendly URL that you can remember. So let's go into this URL, in this case, this URL, and then log into AWS console. Go to the browser and type the URL. You will be redirected into a location to enter your IAM username and password. Now the IAM username is the one that I use here, John, and the password is the password I gave. So it was not an auto-generated one. So I just type the password I was given, and then I sign into the console. Now remember, when I created this user, I selected that user must change the password when they log in for the next time. So I can type the old password that I use, and then I can type the new password I want to use. So I type my new password and confirm the password change. So now I am logged in as the John, the user. How do I know that? You can see that the John is logged in here, and you can see that I'm logged in as John. Now, when you logged in, you may be directed into a specific region. Now, previously I was using Sydney region, and all of a sudden this user got logged into Ohio region. Now, the reason for that is that this login URL has the region as US East 2. If you want to, for example, log this user into a different region, you can always type this one AWS console, and in the region section you can type whatever the region that you want to log them into by default. So if I want to log them into let's say Sydney region, which stands for AP Southeast 2, in the login URL you specify the region as App Southeast 2. If it is a Singapore region, it may be App Southeast 1. So that will make sure that when you logged in, that the default region that they log in is this region. So let's make it Sydney region and then do another login. You will see that instead of logging into your region, now he got logged into Sydney region. This is important, like especially like if you are a company who is operating, you usually want to give access to a certain region. You will very likely use 1 or 2 regions if it is a small scale company. And you want to make sure that the users by default get redirected into certain regions. So that's how you change it. The login URL, you can add this region suffix to log in into a certain region. Now this John the user does not have access to all the places in AWS. Now for example, if he goes into the IAM section, which we previously logged in as a student, he had all the access. But if John logs in, you can see that he does not have access to any of the section, like even the user section he cannot access. Having said that, because we gave him access to S3 section of the AWS console, he has the full access to S3. If he goes to that part of the AWS console, you can find that he has access to the buckets. He can create a bucket. So let's create a bucket. Let's say my awesome happy bucket. He can create a bucket because he has the full access to create an S3 bucket. Create the bucket. And the bucket creation is successful. You can see my awesome happy bucket is created. To sign out from John, you can go into the John and then you can say sign out. That will take logged out the user. If you are an administrator, you may have the need of changing the password of this user. You can always do that by going to the user, going to the security credentials, and here under console password, you can go and click manage, and then you can create a new password. So let's create a new password. You can also disable the console access. So this is sometimes useful. Let's say an employee leaves the company and you want to completely disable that user. You can do it from here. So let's keep like this and then change the password. So that will change the password for the user. AWS supports multi-factor authentication for IAM users, which means that you can enable not only a username and password when they log in, you can also ask them to enter some number or a code when they log in, which is time sensitive. This allows you to prevent any password hacks. So even if a fraudster happen to get access to your username and password, they still need to have access to your multi-factor authentication device to access AWS. So let's now go there and then learn how to enable multi-factor authentication for IAM users. You can also assign a multi-factor authentication device. So let's create a MFA device. So here you can select like what kind of multi-factor authentication device you want to assign for. Here you can see, let's go for virtual MFA device and then click continue. This will give you a QR code that you can use with Google Authentication app to log in into. So what I do is that once I enable this, let's scan this one in my Google Authentication app. And then I need to enter the number that Google Authentication app generate in these two places. So it created ID. So what I need to do now is to enter those IDs. So what I did was I have an iPhone, which I went and then installed this Google Authenticate app. And then I turn the camera on and then scan this barcode, and it then save this special number. So it changes time to time as it is a time sensitive password or the code that you get. So I'm going to enter that code, and I need to wait a few seconds until the next code is generated. And what I'll do is once that code is generated, I'm going to enter the second code that it generated. So a few more seconds, and it generated a new code. So the new code is 412302. So that way I can now assign the multi-factor authentication device. And when I try to log in next time, it will pop for MFA authentication. So let's check that how it works. Let's sign out from this user, log into the console, and then sign in. And now it pops out for MFA authentication code. So you can see that because we enable MFA, now it pops for this MFA code. So let's enter that code, 617.610 at this time of the submission. And you can see that I now got logged in. It's always recommended that you enable MFA authentication for users so that you can make sure that the password compromise is not going to happen in your account. Although we will not go into details around AWS permissions in this tutorial, remember that there's an option to limit or grant access to AWS services based on a condition where you want to satisfy that the user authenticated using a multi-factor authentication device. So how you do this one is that you use in the permission, you specify that this multi-factor auth present true. So all these service access are allowed only if the user is logged in with the multi-factor authentication. Although we will not go into details around creating advanced IAM permissions, in another video that is given under the description of this video, you will find how to go into advanced configurations of permissions to allow this kind of customizations. If you go into the security code, let's say the user lost the device, as the root account administrator who has the more permission on this account can always log in and then click manage, and then you can remove this MFA authentication so that if you want to assign a new device, you can always go there and then manage and assign a code again. Now let's say you assign an MFA device and the user lost the MFA device, and you as the administrator also lost access to the AWS account. Maybe you also had an MFA device and there's some flooding and both of you lost the device that you had. So how can you log in into the account, or how you can recover the AWS again? Your only option is to contact AWS support and then tell your story. You of course need to provide different identities to make sure that you are the truthful owner of the account, but you can still get access to the account after going through a very strong validation process. So I have pretty much removed my MFA device. I no longer need it. If you want to programmatically access AWS, you can use AWS access keys and secret keys. Let's now learn how to use AWS access key and secret key. So if you go into the join the user, go to the security credentials, you'll find that there's a one called access keys. Access keys are useful if your user is not a human being. Maybe it's a software that you use to access AWS. For example, you may have some situations where you want to connect into AWS from your laptop and you want to operate AWS using command line. Maybe you want to operate or invoke AWS API calls with PowerShell. Alternatively, you may have situations where you need to interact with AWS using some software. So AWS provides multiple software development kit that includes Python, .NET, Java, JavaScript, Node, to name a few. So in all these cases, you may have situations where you want to access AWS. So there are two ways to go about and then access AWS in all of those situations. The one which is recommended is to use temporary credentials using Secure Token Service IAM Role. That's a more advanced topic, but description to learn about Secure Token Service IAM Role is given below in this video as another tutorial. The second approach is to use some static keys, which we are going to learn today. And the way to do that is to generate these static keys from here. So you can create an access key. So you just go into your IAM user, security credentials, go to access keys, and then create an access key. When you create an access key, it's going to show you once. So this is the only time that it's going to show you the secret key. You can download it as a CSV file if you want. Alternatively, you can just note it down. So here I created access key and secret key. And then I can use this one in my, maybe in PowerShell, maybe in command line, maybe in my software development kits. So if I close this, there's no way that you can go there and then view that access key. You can also create another access key. So this is important, especially when you want to rotate keys. An example would be if I create another access key, it's going to show me this. It will show you this one and then close it. So I have like 2 access keys. As you can see that once I created 2 access keys, there's no way I can create another access key. The only way to do that one is to delete an existing one. You can either delete an existing one or alternatively you can make it inactive. If you make it inactive, nobody will be able to access using these keys as long as the status is inactive. You can always make it active if you want, so that it will be active and you can use it again. But if you completely delete it, the key is lost and you will no longer be able to use that key. It's important to remember like how you maintain these access key and secret keys. Usually it's not recommended to use them for a long time, because if you leak them, then whoever have access to this access key and the secret key can access your AWS account and get the permissions defined by these policies attached into the IAM user. Alternatively, if the user is a part of a group and you create some access key and secret key, all the permissions of that group is something that those who own these access key and secret key can get access to. Let's now go for a demo and then see how to use this access key and secret key in a real environment. Let's first delete this. I don't need it. I'm going to create a new access key and secret key. I'm going to note it down. So I have my access key and secret key. That's all good. So the next thing is to go into my AWS EC2 section of the console and then use this. You can use it with your laptop if you have Amazon PowerShell install or SDK install or any of AWS CLI install. It can be a Linux environment, Windows instance, or alternatively can be even a Mac operating system. I have this development machine already set up. If you don't know how to set up a simple development environment on AWS, look at the description of this video. I have given another simple example how to start this dev machine Windows instance with some software already installed. Feel free to have a look in that. That will allows you to spin up this EC2 instance. Alternatively, you can do this exercise on your laptop, provided that you have your Amazon command line interface or Amazon PowerShell is installed. Let's connect into this. Get the RDP connection, download the remote desktop connection. I type in my password and I'm going to log in into the account. So I have logged into my account. Because I'm using an EC2 instance in this demo, this EC2 instance has an IAM role attached into that. So if you go into your instance, you will see that because I use the simple development environment I have created in one of my previous video, you can see if you go into the security, it has an IAM role already attached. Now this role provides access to certain AWS services. Because our objective here in this lesson is to use our identity access key and secret key, make sure that these roles attached into that does not have access, that does not give access to Amazon S3. So if you look at here carefully, you can see that as of now, this one allows certain S3 operations. So therefore, what I'm going to do is to remove these permissions. We will come to later how to use EC2 instance roles in this tutorial. For the moment, if you have any permissions attaching to this role, remove that so that your EC2 instance does not have access to these services. Now that's all good. So my instance role, which I have here, my div machine role, does not have any permissions. We will learn about IAM role later in this tutorial. So until then, for the moment, just imagine that this role does not have any permissions. Alternatively, you can completely remove this role attached into the instance. If you go here, you can see modify IAM role. You can completely no IAM role. That will remove the IAM role attached into this. IAM role is a bit of an advanced topic, but we will learn it later in this tutorial. So as of now, it doesn't have one. So let's go into my machine that I started. Let's go into the PowerShell. So there is, if you start an EC2 instance, you will find Windows PowerShell for AWS. If you open this, it will load modules related to AWS PowerShell. So PowerShell is one of the languages that we expose all our APIs. So having said that, we will wait until it accesses and then try to access AWS using the secret key and access key I created a moment ago. If you are doing this experiment in your laptop, you can always use AWS tools for PowerShell. Just install this one, and then you can use this. You can also use AWS command line interface to do this experiment. So I started PowerShell. So let's go into this folder, clear the screen. So one of the command that I can execute is called get S3 buckets. So this pretty much lists down the buckets I have in my account. Because this does not have any access, because I already removed the permissions attached into the EC2 role, this command does not have enough permissions to access it. Having said that, I can use the access key and the secret key I generated a moment ago to get access to S3. Now remember that IAM user John has access to Amazon S3 full access, and the security credentials I'm going to use here is this access key and the secret key I saved when I created this. You can now provide the access key here, which is this one. So make sure that you save this access key and secret keys. And the secret key is the secret key I saved, which is this one. Now let's see what happens when you get S3 bucket. As you can see that it lists down the 3 S3 buckets I have in my account. So this is how you will use access key and secret key. Of course, these are static keys, so they are not secure. They can easily leak through logs output, or if you accidentally commit them into Git repository through your code, they can be lead into some security vulnerabilities. So that's why usually it's not recommended to use access key and secret keys, because they are static values. You should always try to use STS assume role or dynamic access key and secret keys, and how to use them is given in another video given in the description of this video. But you got an idea around how to use access key and secret keys. Now let's say I make this access key inactive. So if I make it inactive, let's go there and then try to access using the same command. You need to give a few seconds, don't try to do it immediately. So let's try to do that now. You get an access key that's saying the AWS access key ID you provided does not exist in our record. So it gives an error. But let's now try to go there and then make it active again. And then try to access the service again. So get S3 bucket, access key and secret key, and then try whether it will work. As you can see, it started working again. But if you delete that access key and secret key, you will no longer be able to use these keys. The other type of keys you can create under IAM User is for AWS code commit. So this is useful, for example, if you are using a Git repository like AWS code commit and you want to use some methods to interact with AWS, but using Git HTTPS API. So you just create some credentials, and that gives you a username and a password for John the user. So when you are using AWS code commit, just you can use this username and password when you try to commit some changes into your code. So I will not go into details. It's a pretty straightforward method. And also there's another one called credentials for Amazon key space. But widely used one is usually this access key and the secret key. And this is where, especially as a beginner, that you should focus on. As you can imagine, AWS environments can have multiple users. Attaching permissions to individual users and managing them is not easy. Usually these users inside your AWS account have different roles. So that could be level 1 support, level 2 support, administrators, read-only administrators, finance team to read AWS bills. So you may have different people accessing AWS account, and it's not easy to manage these users by attaching individual permissions. That's why you have IAM groups. All what you do is you create a couple of users, create some groups depending on their roles, and then attach permission to the group so that all the users in that group get access to those permissions. So let's now learn how IAM groups are created and how to use them. So in my John window, like I have this permission that I initially assigned, in this case Amazon S3 full access. I can always add some more permissions if I want. If you go into attach permissions, maybe I want to give access to, let's say, Elastic Beanstalk. So let's give Elastic Beanstalk full access to this user. Get that permissions. You can always attach new permissions in the way that you like. Also, you can remove them later. So you don't need to delete the user and then create it again. You can always remove the permissions that you have attached. Now, this is okay as long as you have only 1 or 2 users. But your life is going to be hard when you have multiple users. So if you go into AWS console, you can see that I have already created 3 users. One is John, the other one is Kate, another one called Robin. Now, usually these users will have different functional role inside this AWS account. Maybe John and Kate belongs into level 1 support and they only need read access to the account. Maybe they belong into some kind of elevated administrative group and they should have separate access. Now that's where the groups comes into picture. So rather than attaching these permission individually to John and Kate, I can attach permissions to a group and then add these users to that group. So let's create a group. Give it a name like finance team. And then you can, of course, attach a permission. So all the people inside this group will have this permission. So let's say because it's a finance team, we want to give AWS billing access. So go to next steps and create the group. So I have this finance team. I can add users directly going into the finance team and add users from here. You can select which users you want to add. Alternatively, you can go to the users and then select the user and then add that user into a group. So if you click add user to the group, you will see the finance team here. Let's go to the groups and then add 2 users into this group. I'm going to add John and Kate. Add the users. This is all good. And if you go into the permissions, you can see the billing permissions I have attached. Let's go to the users and then check how the policies are inherited. You can see here that there are two sections now. One is called attach directly. So this is the policy we have directly attached to the user. It's not something inherited from the group. And then you have another policy that this user inherited by being inside this finance team. If you go into the users and then click Kate, I have changed her attach directly policy to have Elastic Beanstalk full access. But because Kate is also part of the finance team, she inherits the billing permission. So the permission that she's going to get are what is defined in Elastic Beanstalk and the billing. Now, for some reason, if any of these policies denied access to certain services, let's say here I deny access to Elastic Beanstalk, although she has attached directly this Elastic Beanstalk full access, she will not have access to that because what she inherits from the group denies access to that service. But luckily for her, like you can see that this billing permission does not deny any permission. It pretty much allows only certain services. But for some reason, let's say she has effect deny, and then she denies access to any of these services, she will not get access to that service. A user can be member of multiple groups. So let's create another group called managers. Because they are managers, let's give them administrator access and then create the group. And for the managers, let's add the user. In this case, we are going to add John. So if I add John as administrators, if I go into the John, the user, you will see that there are now 3 policies attached to this user. One directly attached, the other 2 inherited for being in different groups, billing as part of being the finance team, and administrator access as part of being the managers group. You also have a concept called inline policies. So here you can add an inline policy. You can add an inline policy. So these are usually something that you create custom policies you attach. So let's say we create a simple policy here. We are going to have S3, and then the actions we are going to allow few list bucket actions, and I'm going to add few read operations here. And then for the resources, I'm pretty much going to allow all S3 bucket to operate on those actions, review the policies, and that let's call my inline policy. Now, when I create this, now this inline policy has a lifespan of this entity, in this case, the John. So if you delete this John, the user, this inline policy also get deleted. So the use case for inline policies is that it allows you to have one-on-one mapping with the this entity and the policy. So for example, you may have very specific policy that is only applied for John, and in that case, inline policy is a good one. And when you delete the John, inline policy also goes away. You usually use AWS Managed policies when you want to easily share policies across multiple groups. And also, if you go into the policies, which we'll learn soon, you can create a custom policy and then share across multiple users and groups and even roles. So you now know what an inline policy is and the use case for that. It's always for one-on-one mapping with an entity. And it's also to make sure that the life cycle of the policy is same as the life cycle of this the entity. You can remove a user from a group. You can do it from here. So if you remove this permission, or you can see that you can remove it from here. Alternatively, you can go to the groups and then select the team that you want to modify, and then let's say let's remove Kate from this group. AWS by default provides certain managed IAM policies that gives you access to certain AWS accounts as long as you attach into the correct roles or IAM users or groups. These policies are good if you want to quickly get access to certain services, and also they are heavily used when you want to give absolutely necessary permissions for certain services to operate. But in more advanced cases, you need to customize the IAM policies that gives you fine-grained permissions into AWS services. Let's now learn how to create custom IAM policies. Sometimes you call them customer managed IAM policies, and how to use in your AWS environment. Let's now learn how to define your own custom policies. To do that, you go into this policies section. And here you can see that all the AWS predefined manage policies. So if you select here the manage AWS manage policies, that's what you see. Now these policies are good for simple tasks when you want to make sure that you quickly create policies. Alternatively, you want to make sure that you give absolutely necessary permissions for AWS services. These policies are awesome. The challenge you will face with these managed policies, because they are managed policies, you can't modify them. So for example, if I go into this Amazon API Gateway invoke full access, there's no way that you can modify this. So this is kind of a fixed policy managed by AWS. That's why they are called managed policy in the first place. So you cannot modify them. These are all managed by AWS. So that is where the custom policies comes into picture. It's something that you can define. You can specifically define like what permissions are allowed. And more importantly, you can later change them. Imagine that you have a need that none of these managed policies satisfy them. And let's now go there and then create our own custom policies so that we can get fine-grained control over what we want to do. You can use this visual editor to create a policy if you are not familiar with advanced IAM permissions. So in that case, what you select is you select the type of service you want to modify. So in this case, it could be, let's say, our famous S3. And then you can select which actions or which API operations are allowed to do. So in this case, I'm going to select list permissions, and there are like 2 operations, list buckets, let's say. And if you go into read, you can see that there are a couple of read operations. So let's say get object access control list, I'm going to allow. And there are some write operations. So that could be, let's say, delete object or create bucket. So once you give that, this defines the actions. So we will go into in another tutorial how to create these policies, what they actually means. For the moment, just imagine these are the operations that you can perform on a given service. For the resource is the one that really acts on which bucket or place that you're going to access this. So in this case, I'm going to specify it for all resources. And then I can create this service. So before that, you can go into this JSON document. So that visual editor created this JSON document. So in that case, you can select this service. This could be the starting point. So if you first start with the visual editor and then create this policy and then later modify it. So that's a potential thing that you can do. Alternatively, instead of doing it with this visual editor, because sometimes it's difficult to go and select each services, you can go directly to this JSON editor and then paste your policy. So I already have created the complex policy. What it includes, we are not going into details. We will learn it in another tutorial. As you can see, I have the actions that I want to allow. So that includes specific API operations, in this case, get tags and get resources. You can also make wildcard inclusions, for example, all the list operations and get operations of SNS and SQS, some different services. We will go into this meaning of these JSON document later in another tutorial. The AWS IAM policies itself is another complex subject. So let's make it in another tutorial and learn how to do that. If you have any errors in the policy document, it will highlight when you try to create it. Here you can see that there is a red box that highlights there's a problem. So you need to make sure that this policy is accurate before you can submit. So if you try to review and publish it, it will throw an exception and then show in that error message. The problem here is that if you look at carefully, one of the bracket is not properly closed. So if you go up in that, you can see that the statement, there's a square bracket that is missing. So let's correct it and then try to review it and then submit it. So all looks good. Let's publish this policy. I want to give it a name. So in this case, I'm going to call it my first policy. Of course, when you name this one, you need to make sure that you give it a meaningful name that represents what this policy means. So you can give it as my first trial. And then you create this policy. So once you create this policy, it will appear as customer managed policies. So that's why we say them as custom policies, or sometimes you call them as customer managed policies. Unlike AWS managed policies, these customer managed policies, you can create them and also you can modify them. So later, if you want to go there and then modify them, you can always go to edit policy and go to maybe the JSON one, and then you can edit this policy. So you can add SNS list permission. Maybe you don't want to have this, you can remove this statement here and then review the policy and then save it. So you can see that when you save it, these customer managed policies have a concept called versions. So if you go to the policy, you will see that it has something called a policy version. So if you go into these versions, you can see that under version 1, I have this SNS list operation, but in the version 2, I don't have that SNS list operation. Now, once I created this, of course, I can go back to a previous version. So I select the version that I want to go back and then set as the default. So then that becomes the default version. So if you go into the permission now, you will see that it has SNS list operation. You can always go to the policy version and then select the next version. And then the permission will not have SNS list. You can keep up to 5 policy versions. And that's an easy way to go back to a previous version of a policy that you created. Now, once you created this policy, you can attach into either to your users, groups, or roles. So let's go into, let's say, a group. I have my finance team. I can go to the permissions and then attach this permission. So in that case, filter policies, you can select customer managed policies. I have my first policy, attach the policy. And you can now see that my first policy is attached to this group. Similarly, you can attach it to a group. Let's say I want to attach it to Robin. So I can go to that permissions, attach an existing policy directly. You select the policy type, customer managed one, and then attach this policy. Next review, add the permission. Now I added this one to 2 different entities. I added to a group and to a user called Robin. So if I go into my policies and then select that custom policies, custom managed policies, I can select that. And then I can go to policy usage and then see that this policy has been used in finance team and Robin. If I make any modification to this policy, now the amazing thing is that it gets reflected across all these entities. So the whole purpose of having these customer managed policies as opposed to, let's say, inline policies is that it's a shared resource. It's shared across this account. It's not shared across multiple accounts. But when these policies change, it affects all these 2, in this case, this finance group and the user called Robin. You can also attach the policy to a role, which we'll learn later. And in that case, if you change that policy, it will affect that role also. AWS IAM role is one of the most misunderstood concepts in AWS IAM world. So let's learn some basics about AWS IAM role and how to use it in your day-to-day operations. This is a foundation course. If you want to know more about how to assume IAM permissions using Security Token Service, I have given another video in the description section of this video. Before we go to a demo to learn about IAM role, let's learn some theories. An IAM role is an AWS resource, a resource similar to an EC2 instance or IAM User. It's an AWS resource. You can attach an IAM permission or multiple permissions into a role that defines what actions are allowed to those who assume this role. So once you define the permissions, you pretty much attach these permissions to a role. A role can trust some entities. It can trust an AWS account. It can be your own account. It can be one of your customer or partner accounts. It can even trust multiple accounts. It can trust an IAM user. So this IAM user may be one of your IAM users, or it can be someone else IAM user. A role can also trust another role. This another role can be in your account, or it could be someone else's account. It can also trust any other AWS services. So these services include things like Amazon EC2, AWS Lambda, or any combination of these. You can even trust Amazon ECS task. So here I have given only a couple of services, but there are so many other services a role can trust. It's important to note that not all services support role trust. It's only some services that supports it. A role can trust any combinations of these. For example, it can trust an AWS account and AWS Lambda and EC2. Once it establishes the trusting entity can assume the role and get the permission of that role. For example, let's say an IAM role trusts an IAM user. That user can perform an action called assume role and then get the access permission defined by that role. If the role is attached to, for example, an EC2 instance, that EC2 instance can assume the role and get the permissions defined by that role. Let's now go for a demo and then see how an EC2 instance can assume a role, permissions defined by a role. We will first create a role, attach some permission into that, and then trust EC2 instance to assume that role. We will then go inside that EC2 instance and then try to access an Amazon S3 bucket to check whether my assume role permission works. This is useful especially when you are running some code. For example, you may have some code running in your Amazon EC2 or maybe Amazon Lambda functions, or it may be running on some task in your Elastic Container Service. So once they have this role trust, that code running inside your Lambda or EC2 can access the services defined by those permissions. An example is, imagine that you have a Lambda function that needs to access a DynamoDB table or an S3 bucket. The Lambda function can assume that role and get the permissions related to that and then access the service defined or permitted by the permissions. I have started this development machine. If you don't know how to quickly set up an EC2 instance on AWS, check the video description. There is a CloudFormation template and an example how to quickly set up a development environment on AWS. So once you start this instance, you can see that I have attached an IAM role. This IAM role grants certain permissions to this EC2 instance. So every time any software that is running inside this EC2 instance wants to access AWS, the permissions defined in this role will grant those access. So if you go into this my div machine role, you will see that as of now, I have removed all the permissions as part of one of the previous labs. This is an IAM role. As you can see that it has this role, my div machine role. And similar to the users, it has a section called attach roles. You cannot add them into a group, but you can attach permissions into them. So let's say we attach a permission, and you can attach any permissions you want. Like for example, let's say we add Amazon, let's say we add S3 full access. If you give that, any program running inside that EC2 instance will have access to Amazon S3. It's important to know the trust relationship. This is where that tells what this role trusts. So remember, the role can trust a lot of other entities. So as of now, if you go into edit trust relationship, you can see that what it trusts is EC2. If you are trusting a user, it may be an Amazon EC2 user. You can trust on another account. So in that case, the principal will be an account. You can trust another AWS services other than EC2. It can be Lambda, for example, to assume this role. What it means is that this service is in this case, the Amazon EC2 instance is allowed to assume this role. So this is what this policy says. If you want to know more about this trust relationship, feel free to look at the description. There I have given how to use STS assume role permissions to define these trust relationships. So I have defined this. So this is I'm using a role that I have already created. If you want to create a new role, what you go here, you go to roles and then click create a role. So when you try to create a role, it asks you to define what type of a role that you want to create. So you can have a trusted entity as another AWS service. You can trust another AWS account. So in that case, you define what the account ID you want to trust. You can also trust a Cognito identity provider. So this is another AWS identity provider. It allows you to have large number of users. And also you can trust any other SAML providers. So that can be, for example, Azure Active Directory. It can be a Google Authenticator that you want to trust. But in our case, we are going to trust an AWS service. In that case, it's going to be EC2. But there are so many other services you can trust. You can see that it can be Lambda, API Gateway, Comprehend, Config, Forecast, Mercy. There are so many other services that you can trust as part of this role. So the role will trust, let's say, EC2. EC2 can assume this role. If the role is trusting Lambda, Lambda can assume this role. You can also have multiple services. For example, you can have both EC2 and Lambda or some other combination of these. If you specify like that, then all these services can assume this role. Unfortunately, in this UI, you can only create one service at a time. But that does not prevent you adding more services later once you create that trust relationship. Let's for the moment assume that the role is trusting EC2. Go for the permissions. I can attach something like S3 full access. And then next stage, create a review. So this role name is going to be my awesome EC2 role. Create the role. So if you go into your role section and then search for your role, you can see that you have my awesome EC2 role and the trusted entity is EC2. You can always trust another entity. So to do that, you can go here and then edit this trust relationship. For example, let's say we are going to create a trust relationship with another one. Let's create another role that trust an account. So let's create a role. In this case, it's going to trust and another AWS account. Provide the account ID. And then you can specify whether you need MFA when you are trusting or using this account. For the moment, we don't need it. Just click next permission. Let's attach the same permission, for example, Amazon S3, full access. Go to next tag, create preview. Let's call this my awesome account access. The one my awesome EC2 role and my account access role. You can see here the trusted entity is EC2. So that's why this role allows EC2 to assume this role. If you go into the account access role, you can see the trusted entity is an account. The way that you specify is statement allow principal, this one, assume role. You can always combine them if you want. So as you can see that here it's a service that it trusts. In this case, it's an AWS account it trusts. As you can see, this statement is an array of JSON elements. So what you can do is, for example, you can allow this EC2 permissions. Not only that one, you can also add the comma and you can trust multiple entities if you want. So in this case, it's going to trust both EC2 and the account. So if you update the trust policy, you can see now it shows you two things. Trusted entities are EC2 plus the account. Let's for the moment remove this account. We don't need it because we are going to use this role inside our EC2 instance. So update the trust policy. That all looks good. So let's now use this my awesome EC2 role with my EC2 instance. So as of now, I have my due mercy machine role policy. So if you want to change the machine role associated with your EC2 instance, all what you need to do here is to go into instance state and the settings, modify IAM role. You can then select what role you want to have. So in this case, I'm going to select my awesome EC2 role. Click save. So now any program running inside this EC2 instance have this permission. If you go into security, it's now going to use my awesome EC2 role. So let's log into this machine and then try to access AWS services. So in our previous video, we access AWS using access key and secret key. As you already know that this is not a good practice because these keys can now leak through some logs. They can also leak through some human mistakes. So this is not a good practice. But the good thing is now I have attached a permissions into this EC2 instance. I can do the same thing, but without providing access key or secret keys. So let's say now, let's leave this one here. Let's say we are going to say get S3 bucket. So let's previously when we ran this get S3 bucket, you got an access denied because this machine didn't have any role attached, or the role it had didn't have the permissions. So let's clear the screen. Let's now type get S3 bucket. And I'm not going to pass any access key or secret key because the machine itself has a role attached into that has those permissions. So let's type get S3 bucket. You can see now even without providing access key and secret key, I got access to this S3. That is because this get S3 bucket will try to use this role when it tries to access it. Let's try to type get S3 bucket verbose and then check what will happen. You can see that in invoke Amazon Simple Service list bucket operation in this region. Let's now try to remove the access to that role and then see what will happen. So I have this my awesome EC2 role attached into the EC2 instance, and that awesome role has S3 full access. So let's remove this. Remember, like when you remove it, the effect of that removal will not be immediately visible. So you need to leave some time for it to access it. So if I do the S3 get bucket again, you can see it works because the access key and secret key that this machine got is valid for some time. So you need to make sure that it's you leave enough time for this to expire. And then if you do the get S3 bucket again, it should give access denied error. So let's check what will happen. You can see it's still working. The reason for this is that the token it got is not yet expired. But how do you know when it will expire? So inside the instance, if you go into the metadata URL, which is in this case, you have this JSON metadata URL. You can see that under here you have something called IAM. If you go here, you will see the IAM. And then there is another one called security credentials. So this is the security credentials that the EC2 instance got. You can see that is my awesome EC2 role. So let's go into that one and then see what will happen. So here you can see that this role provided some access key and the secret key. And as you can see that it's last updated on this time. So make sure that your key expires. So once you do that, it usually expires in a few minutes time, not a long time, or it get refreshed. So what you can do is go here and then type it again. Let's see whether it will work. Still works. So let's close this entire PowerShell window and then start it again. Hopefully when I try to access it again, it will expire. So let's try that, get S3 bucket. As you can see that it has expired. So I think what happened was that the session had, the PowerShell session itself had the access credentials. So once I closed the PowerShell session and then start it again, then it worked. Alternatively, once that expiration period goes away, it will be automatically expired. So let's try what will happen here. Let's refresh this. As you can see that it has updated that token. So when you make some modification into the IAM permissions, that this the credentials is getting usually get updated. So over time, like very quickly, give some minutes. After that, the expiration will happen. So this is all good. So we now know how to attach a role, how to grant permissions through an IAM role to an EC2 instance. The process that happens behind the scene is pretty much similar to any other service. So if you want to grant access to AWS Lambda, some access to let's say S3 bucket, you can attach a role into that and then give some permissions to that role. So the Lambda will have access based on the permissions that you have defined in that role. Similar to IAM users, you can of course attach a policy. You can also attach an inline policy. So similar to IAM users, if you attach an inline policy, the life cycle of that inline policy is same as the life cycle of my awesome whatever the role that you have created. This is useful, for example, if you have a role specific permissions and you want to make sure that permissions get deleted as part of deletion of that role. So if you want to have a shared policy, make sure that you create that shared policy here and then share it across multiple roles. But if you want to have a specific policy that is only specific for your role, make sure that you use an inline policy. As before, for IAM users, you have something called a permission boundary. What it means is that if you specify some services on this permission boundary, and you then specify some permissions under policies where you try to access something which is not defined by permission boundary, you will not have access. So boundary itself limits access to what services you can access. For example, let's say you give access to Amazon S3 and Elastic Beanstalk in permission boundary, but here you are going to access in the permission policies, you are going to access, let's say, container services. You will not have access because you only have Elastic Beanstalk and S3 access in the permission boundary. If one of these permission boundary denies access to a service, or one of your inline policy or any of the permission that you have defined denies access to a service, regardless of whether you allow these permissions in your permission policies or inline policies, doesn't matter, it's denied by default.